Hello and welcome to Shaastra Arambh. Today we have with us another guest who has been featured on Shaastra magazine as well. We are joined by Mr. Gokul NA, the co-founder of Cyn Lr. Thank you so
Hi,
much for
Pratibha.
joining us, Mr. Gokul. Hi, good morning.
Pleasure.
So thank
Pleasure.
Yes, and thank you so much for joining us. So just to start the conversation, Cyn Lr is a very unique name. Could you tell me what uh, got you to think about a name like Cyn Lr for your organization?
It's a short form. I mean, it's not that fancy either, but it's a thoughtfully done short form for cybernetics laboratory, and conceptually it evolves from the idea of a counter narrative towards the way machine learning is approached. So there is a school of thought around AI where there is a single monolithic block of understanding about intelligence, whereas cybernetics is a subject from which this idea of AI even evolved, but which thinks from intelligence as mostly as an outcome, not as a source, where small, simple things working in tandem with each other suddenly, exuberates a very complex behavior, where they are able to handle a very sophisticated things. But each simple, small systems, self-regulating systems who are able to handle their small portion of their tasks, when they are given the flexibility to arrange themselves in a certain way, the idea of cybernetics comes about, where it kind of the study of doing that is essentially is called cybernetics, and it gives the more sophisticated intelligence starts getting evolved from that behavior. So that's the thought process from which the name cybernetics was actually taken, and laboratory is the place where, and since we are automating labor, laboratory is the place where the labor happens, right? So essentially that's where the evolution of labor is what we wanted to name it, and that's a thought process which laboratory was named, not the typical lab, essentially, but yeah, yeah.
Could you share your current products and services?
Right. So, Cyn Lr, just as a general context, Cyn Lr is a technology building company than a technology using company. So, what we try to do is, build for the missing pieces that are there in the intelligence stack to be able to make robotic arms specifically as autonomous as a human baby, or as intuitive and autonomous as a human baby, where without much context it can handle objects. Right today, either you have to control the environment to a very large extent inside a manufacturing plant to make an automation system work, where you arrest any variations in the environment, including the lighting variations, right? And that's how much you have to do to make a visual system work, or you have to go with an extensive preliminary training and so on, so which usually is not feasible for you to handle for all variations that might happen, even though in a controlled environment, right? But on the other hand, a human baby may not even have seen an object. Like if I pull out my keychain and then give it to a person in the front of me, they may not have ever seen that shape, but they will use their vision to go pick it and then start rotating and then seeing it in the first place, right? So you didn't have the prior need for knowing what that object is to be able to handle that object. So that's the first intuitive layer on which we build. Our intelligence is built on. Human intelligence is built on. So that there is that missing gap which is not usually focused in the world of automation, and in the world of machine learning for that case. So those are the gaps that we build. That starts from the way your vision even happens in your eyes, and all the way till your hands. From the customer perspective, what we are trying to give them is a product that simplifies automation for them, that removes the need for custom machinery. So possibly many may not understand how today automation inside a factory happens. So maybe I'll also just give one small background on that. Typical robotic arm. So some of those that you see in the background here, right? So there's one in the three form, there is one in just one single arm form factor. Uh, a solution in developed nations would cost anywhere between $150,000 to $250,000 to adopt that one robotic arm to be able to do a particular task, out of which $30,000 to $50,000 is your typical robotic arm cost, and remaining is all about arresting your environment. How do you bring your conveying systems? How do you bring all those presentation of parts and so on and so forth? So it's like you buy a refrigerator for 30,000 rupees, and you spend another lakh to kind of put the plug into your power socket. That's how much is the amount of customization that goes around. So what we are attempting to do is, and in fact, that customization changes from one object to another object. Like if you're picking a bolt, or if you're handling a bolt, or in another station you're handling, let's say, a washer, the whole customization will look entirely different. Just as simple as that, those two pieces will look entirely different, right? So we are eliminating the need for that hardware customization, essentially, and that happens because robotic arms are blind today, and they cannot, and even with the camera, they cannot adapt and adjust to what is varying, which for which they are not taught, and most of the variations are not, you can't be teaching all of them for. So you want the system to be able to dynamically adjust to that. So if they are able to adjust, you don't need arresting the environment, right? So what we do is simplification of automation, essentially, from that front, and simplification of manufacturing at the end. And what we envision is there is going to be one standardized machine, like a laptop for automation, where anything that you want to modify, it's on the software level, but hardware wise, it's the same device that you use for one task to another task, or one automation to another automation, or one object to another object. So yeah.
Understood. So this is how perhaps Cyn Lr's vision systems differ from the traditional robotic vision systems, if I understand that correctly for the context, correct? Right. So I also wanted to understand, how does your system enable robots to operate in like very unstructured and unorganized environments, and what are the challenges that you have to overcome in getting there?
Yeah. One of the I want to give this background, right? So again, this is again not in the popular media. Essentially, it's not like well discussed. Putting a camera on top of a robotic arm is not a new thing, right? People have attempted it for more than like 50 years. One of the earliest, I'm not able to find the video still, but it used to be an MIT lab where they used analog cameras in 1970s. Robotic arm came in 1969, first commercialized robotic arm, Unimate. But they were trying to put that together, and then they were trying to pick an object, handle that object, assemble parts. So this is all attempted for very long period with vision. People understood that vision is needed. Except the way vision has evolved has been from a color, image, and identification perspective, right? So if I want to go handle an object, first I look at, take a color sample of that image, template, search that template in the environment. Wherever the template matches, I'll go and ask the robotic arm to go pick. This is a simplistic understanding with which we evolve, right? And except that object manifests in variety of colors, variety of orientation and shapes, so it becomes very hard for us, right? Now, every time if the color changes and the system fails, what do? We go back and then modify the template. We used to do that manually, and we used to do that in machine vision back in the time, in 2000s. Then came the idea of machine learning, where we said that instead of a person tweaking the algorithm to detect aspects of that image, we will make the system only to evolve those templates. So this is how the traditional system is, right? So the approach of computer vision today is see color first, then understand color patterns, and then based on color patterns, construct depth, then go and approach an object and pick. On the contrary, human eye, this whole system actually kind of fails if you are not able to recognize that object. If I'm not able to identify A, B, C, let's say in this clutter, if you're not able to see where exactly the robotic arm is, then I can't go pick them, right? But if you throw an object in front of a baby may not know what that object is, A, B, C, what it's not, right? He'll just go grab them, put it in its mouth, throw it, pull your spectacle, pull your hair, it'll do all of that, right? So it's able to kind of manipulate an object that it doesn't even know, where you don't have to train them or label them A, B, C. So that happens because human eye sees motion first. That's the fourth layer of your eye, but which defines what an object and what not an object is, right? Simplistically, when things move, I touch a particular something that is very interesting as a contour. Let's say this color is very interesting for me. I'll go touch this portion of it. Suddenly the bottom portion also starts moving, right? And your fourth layer of your eye is able to immediately, put together, which are all the highlight only the contours that move together. So your brain assumes that whole area that moved is one object. So that's how quickly the system is able to put them together. Second comes, there are 18 different ways of constructing depth, right? Out of which probably 6 are primitive cues that we have evolved together with, and the rest is all learned cues, which are more sophisticated, right? And we don't take, like, unlike the current 3D cameras, where first you take the whole scene, construct 3D depth for every pixel there, then you start processing. Human eye, while I'm looking at my finger, there might be one portion to which I have depth, and the rest of the other portions I may not have depth at all. It starts evolving, as you start collecting more and more details. It's sporadic but more precise depth that it actually keeps getting, right, of what is system of context. And it has 18 different cues, starting with your autofocus in itself. We think autofocus is to see sharp images. The lenses are there to see sharp images, but actually it uses autofocus for the preliminary layer of depth. Then it starts using several other cues like your convergence, your eyes moving. So nowhere across the globe you have a 3D camera that is used for moving. So in fact, most of the 3D depth cameras today are pattern projected. They're not stereo vision based, because construction of stereo vision based depth becomes very complicated usually and algorithmically heavy in the traditional way, in a Euclidean geometry perspective that you want to build. So what happens is we ignored, or we removed the necessity for both lenses, where we say pinhole approximation, and we have removed the necessity for eye movement. We think it's an unnecessary evolutionary trait that most animals have, but actually that's a foundation by which we are able to use this vision. The convergence is the basis by which we are able to construct depth for even unknown objects in the scene, completely unknown objects in the scene. So that's a second aspect that actually comes. Like this, there are 4 other aspects that actually comes, including your motion as the depth, right? You have seen the cartoons where a character moves faster and the mountains move slow. Your trees move slightly faster and the 2D character moves even faster. So it gives an illusion of depth between all these 3. So those are things that we use as cues. Then comes color, which is very, very subjective, right? If I ask you what is the color of the paint on the whole of the roof and the pillar, you would say they're all same. It's just one color of paint. But for the machine, that is gray, right? And then suddenly something else is bright white, right? And something else is yellowish white. So this is how a machine would put together. So if you remember, the whole internet was split between a blue-black dress and a white-gold dress, whether it's a white-gold color or a blue-black. So that's how subjective our color construction is. We can't base a whole intelligence based on that as an objective information. Color only differentiates an object, doesn't put together an object. Like for example, even your own background of yellow, or my own shirt for that case. Look at the number of hues and contours that it actually has. So it's very complicated. How would a system be able to identify all of this as one system or put together a system? And you can't go about millions of images for every object to be able to train on them, especially in an industrial scenario where you have very limited access to those kind of information, or limited number of products on which you can even have that variations that you can capture on. So so there comes the issue of having to make it completely dynamic, right? So we follow this whole 3 capability for the system to be able to completely be autonomous in a scenario, to collect information the way it wants and then process them. That is necessary for it to do a meaningful action on a contour and go pick an object. Like one of the problems that Amazon still faces, and they gave it to us, is their YOLO models and models that they have built is good if I have an individual object, but I can't control its orientation, because if I change the orientation, suddenly you see the reflections changing, right? Okay. And it becomes an issue. For a shiny object, it's an issue. Now, most of these, on the other hand, come with a plastic wrapper on top of this. Now, the plastic wrapper, there is no way for you to kind of control the reflections on top of it. So it becomes like wildly different kind of colors and so on and so forth. So when you have multiple objects bunched together, or it's on a wrapper, they don't essentially become recognizable, nor can they go act on them. So these are like foundational problems. Starting from there to a simple task of picking a bolt and then placing into a screw hole without slipping a thread is an unsolved problem across the globe. That goes for your car, your electronics, mobile phone, whatever that you assemble across the globe. Today, it's all majority is entirely manual. There are very few, automated mating of parts that you would see across the globe, right? So these are the layers that we are simplifying and we are trying to solve, and that's where our vision stack enables these possibilities to be, that they can operate on objects that they have never seen before, handle those objects, pick those objects that they have never seen before, and can apply the right force and grab them and grasp them and then mate them. So.
Right. You did outline the role of AI and machine learning a little bit in the work that you do. Could you also let us know about the role of AI and machine learning in enhancing the capabilities of Cyn Lr's vision systems per se, and how do you intend to, how do you see this growing in the near future?
Yeah. I think I think you have to delve. So instead of looking at the machine learning just as a block that you could actually use, Machine learning in itself is in a very nascent stage. I don't subscribe to the word AI so much because artificial and intelligence, neither are these are very clearly defined. If they are not defined, then they are not empirical. If they are not empirical, then you can't. It's not scientific enough to be applied in an engineering, right? But machine learning is a very, very thoroughly thought about approach and subject that we have. But the approach has so many different methods. Neural networks is one of the significant methods that we use within that approach, right? And the architectures of how neural network in itself is built in itself is evolving. The understanding of that itself is evolving. And today, the limitations or where do they stand is what we call as a linear approximation of a system or of a mathematical curve. So if I have a circle, I can plot the circle as small straight lines, right? So that's how you have made your whole neural architecture. Its assumption is all neurons are doing an, y is equal to mx plus c, where m is the weight, w, and your value, which is x, plus b by s that you actually put. The c becomes a b, right? And the assumption is just the number of neurons that you give and how you kind of tune the weights for them. So this is how it's assumed, essentially, that you could construct a complex polynomial or whatever the equation of the system is. But the human brain, each neuron has a different function in itself. Each of them are complex polynomial in itself, right? And they are time-oriented machines. They are not a simple data moving from one end to the other end, one multiplication over there, and then one tuning over there that you do. They're a more complex time-oriented system. Each of those neurons have a specific function, and the neurons, the way they have assembled themselves around, allows you to learn in a certain way in real time, right? Not a pre-trained back propagation based training system where you have. So the idea of machine learning is essential for us to build, because that we don't compute mathematical equations in our head and then solve some things. We have a very different machine in our head that actually does that. But the way we have gone about approaching is insufficient today to solve the problems that you are dealing with. So we are building some of those missing layers even at the machine learning aspect, where we are vision transformers and all of those concepts that actually come usually are just a simplification aspect of what our brain goes through in breaking them, right? I mean, taking the traditional computer vision APIs and kernels and then you are just training them, that's insufficient. We need to build a lot of these pre-factored layers, just like I said, motion, right? Motion identification in itself is a specific neural activity. You can't pick that neuron and then put it in another place and then make it work like another neuron. It doesn't happen, right? Whereas in our ML models that we build, neural network models, you can pick a neuron from one place and put it in another place. It will still work with a very similar functionality. So it's not that plug and play in our head in the way that goes. So we are building those layers foundationally. And in general context, reinforcement learning is very insufficient to perform actions like this. So even that has to be foundationally built from scratch for us. So that's another layer that we are also kind of contributing to build more.
Right. So how does Cyn Lr's technology adapt to different industries and applications, such as you mentioned manufacturing, logistics, or healthcare? Is there scope for this technology to explore more such sectors, and how are you tapping into it currently?
Absolutely. So, like I said, we are a foundational tech building company, and obviously, the only way to demonstrate a technology for the customer doesn't care about the tech at the end of the day. He doesn't care about whatever that your fantasies are, and they have a pain point. They need a solution for the pain point. So we do take this as an entire complete solution with a packaged hardware form factor, because the 3-arm with the head with another spine and things, so that it can. It's not essentially like a humanoid, not so humanoid, but it's a form factor that we find it very convenient to solve for most of these applications, which does take some of the freedoms inspired by how human body is, and of course human body is more superior than what we have thus far built. But replicating human body is also very costly from that front, right? So we have made use of what's available, and then we have done what of the best that we could. But application wise, we are sector agnostic, right? So wherever we need two parts to be picked, oriented, and then placed together, which is any task that you take, be it writing with a pen, or be it opening the cap of the pen or putting the cap of the pen back, it's all a combination of picking, orienting, and placing, right? So any sector that needs a machine to interact with an object, pick them, and then start mating them together. For all those use cases, we are relevant. But that said, the ease of adopting a new tech, industry that has equipped itself to adopt a new tech or an insufficient tech, because we are at a very nascent stage, but someone should be able to profit out of such a technology, right? And should be structured to profit out of it, which is usually automotive. Because even more dumber a machine like a robotic arm, which is just it doesn't justify the word robot, but because just 6 links with motors, and you use a joystick to move to a particular position, and keeps repeating that at 20 micron repeatability every time. That's a phenomenal feat, engineering feat, but not an intelligence feat at all. There is no intelligence inbuilt in the system. But yet they are able to utilize that system and then be able to produce cars and manufacture them. Not even electronics assembly industry, including a mobile phone or your laptop, have learned to utilize robotic arms to that extent. So because of which we are beginning with automotive as our primary customer. Along with that, we have warehouse. We also have electronics assembly. We also have in specific and specialized cases where we have interest coming from lab automation, which could be your biomedical labs or even your what we call as HIL testing for your aerospace and your, like you want to parameterize your engine or you want to just test some of your ECU, engine control units, or your in your car and so on. So they have to wire a lot of different things in a lot of different ways to test that hardware. So they want to kind of reuse a device that can be repurposed continuously for multiple different applications, which doesn't depend on external environment or external constraints, or another application that people actually look at. From there to even recycling for the case. But these are all like outliers. We don't know yet how market will react to it and how our product is fit to that market yet. But what we initially see from a sales cycle point of view, convenience of sales cycle point of view, is automotive and discrete manufacturing from the front. So yeah.
What do you call your specific products that you've developed so far?
We have 2 platforms. One is CLX and the other is Cyro. CLX is the vision platform, so which includes the whole hardware, which is the camera in itself, which can have the autofocus and convergence and some of the physical layers of what I spoke about as motion, color, and so on. And then the whole layers of neural net that comes on top of them, some of the primitive neural layers that come on top of them, and the API stack, which will help engineers to program further on top of them. So that's a platform. Now that combined with the 3-arm robotic arm robot system, which you might be able to find them in the background there, which is a 3-arm system that actually usually is, helps to be one universal solution for picking, orienting, and placing any object with force feedback sensing, with grippers that have force feedback sensors, and the whole algorithm layers that come on top of them to be able to go perform a particular task. So these are the 2 platforms, CLX and Cyro.
So it's very evident that you've done like a lot of research on the subject before you entered the industry and everything. So may I know a little bit about the story of founding this Cyn Lr? Can you tell me a little bit about your background and how you got interested in this whole technology aspect of it and built Cyn Lr?
For us, it has been a very long journey. We didn't just stumble upon the tech and then suddenly just quickly start. Of course, we don't have the clarity that we have today, and it'll be a lie to say that we envisioned it the way we. So it's founded by 2 of us, Nikhil, my partner, and I. We both met each other at our first job at National Instruments, probably under almost 12 years back, where we both joined in the same team, and then we started evolving into different career roles. So there is a journey for the problem, and there is a journey of us with the problem along with it, and how we methodically kind of learned to do with it. So we did our PhD. Nikhil keeps putting it this way, that we did our PhD with the customers, not in a university, and that's how we evolved the whole thing. So I joined into National Instruments as a machine vision specialist from an application engineering team, and then evolved to become a machine vision specialist. So along with it, I also was doing a bit of an RF and embedded, and there used to be a software product called LabVIEW, and then used to be an architect in that programming language, essentially software architect in the programming language. So I did a bit of a mix of these roles at National Instruments, but predominantly focusing on machine vision. So it's a big segment within them. while Nikhil also joined in from an application engineering and then evolved to go more towards the sales, where he was interfacing with the customers and taking the customer problems directly with Intel, Cypress, and GE Healthcare, and GE John of Welch, and Honeywell being his customers, Bosch and Honeywell being his customers, and so on and so forth. So while I grew to be responsible for machine vision applications and architecture across whole of Southeast Asia, excluding China, which is Taiwan and Malaysia, Singapore, all of these places, India, Arabia, Russia, and Europe, where I was responsible for some of these key vision architectures that used to come. And NI's R&D segment for vision was based entirely out of the software side was entirely based out of Bangalore here. So that's how the exposure into the problem started, right? But my journey into the exposure of the problem started earlier when I wanted to build a robot when I was in the college, specifically for harvesting coconut plantations and how it could climb, because it's one of the most sophisticated problems when it comes to harvesting and so and so. And me being, I grew up in a farm, essentially borderlining a city. I don't know, Arvind Swami's life is very similar. Mine was very similar with that. Schooling was something fine, but I grew up in the farm on the other hand, so well exposed. So we had close to around 1,000 trees, and in the neighborhood and all the other farms and everything were struggling to get. So it's slightly well mechanized even at a time when I grew up, right, in early 1990s and late 80s. Even at the time it was mechanized, but we had a huge problem about labor shortage in doing any of these, especially onto the coconut climbing and things. So problem came from a very different way, and then I didn't think of it early, but when I was in college, I wanted to kind of focus on this particular problem and see if I could solve its more complicated issue. And the center of the problem came to the point thinking, why aren't robotic arms that easily usable to put into a tree, right? So there came this resonance with Bill Gates' statement where he said, if automotive followed the Moore's law, they would have been cheaper to throw a car and then buy a new one than refueling it, right? So, but that statement, I don't think it was well founded, because the complexities from a data point of view is much lesser compared to what it is in the hardware point of view. But I certainly did agree that electronics in itself also had such a complicated mechanism, and they did become much more efficient in the way they actually build things, and volumes make a huge difference in those cases. So it boiled down to an aspect that volumes are a. I was just, when I was doing my project, I was just, Coimbatore is a place where every house will have something as a lathe behind there. And there was one guy that was casually talking on that day. He was saying that, if we make the screwdriver, it will cost us 1,000 rupees, but it's just 10 rupees if I'm going and buying it from the shop. What makes it? And then they were just discussing how volumes and production and so on. So that resonated, that simple thought at that point resonated so much. And somehow I was again very clearly thinking that if I have to make this robot system work really well, and you need a hand to be that light, to be portable into that environment, to be that rugged. A car is that rugged, and it has been portable into that environment, and so on. So volumes make a huge difference. So that ecosystem is built around them. So then came the question of robotic arms had been there for a very long period of time. Why exactly haven't they become this cheap and this affordable? And they're much simpler than, as a machine, it's way simpler than a car. Car is extremely complex, and your ICs are also like phenomenally complex, right? To even have an applied materials kind of a company to be built just to make machinery to do your lithography and so on and so forth and all that, right? Robotic arms are very simple machines, just 6 motors. That's it, to put on a link. Maybe I'm over trivializing, but compared to what they are, right? So what the car is at the end of the day. So why haven't they picked up? What is not happening in the industry? So first thing is to go with the idea like Tesla, to go to the industry that can afford, because technology is nascent. But even that industry is not adopting it, in large scale, because it's not applicable in large scale as it is. Your laptops are, you don't think about what you want to buy a laptop for, right? You buy a laptop, then you decide what all applications can you install on top of it, right? Customer today is not buying a robot and then deciding what all automation can I do. He first has to understand that whole 70% of the investment that goes in all this hyper machinery around it works. Then I can buy a robotic arm which can actually augment that whole task, right? So how do we flip that? How do we remove that? So that's a problem that was there in the dynamism, and it is with that understanding that I went into National Instruments, seeking a job there, and then luckily enough, got a job. And the problem was very similar. Machine vision as a domain had been suffering, where if I attempt 10 problems, only 3 would commercially succeed, 7 would fail, right? And this is across pioneers like Cognex, Keyence, and National Instruments, all of this, right? And the key problem that I noticed there is it is over trivial. Vision is over trivialized to an extent where, if I want to give the ratio of how much we have over trivialized it, uh, all of your ML evolution today for your language and all the other proprioception is only to 9 to 11% of your brain processing at any point of time. More than 55% of your brain is essentially occupied, of your processing is occupied for visual content. That's why you close your eyes. If you're smelling a rose, if you're tasting ice cream, if you're touching a velvet, or if you're listening to music, or if you want to focus on other thoughts, first thing you do is to shut your eyes so that the neural activity is available for the rest of the other places. So how hyper trivialized have we done it to just an identification machine, right? So vision is not an identification machine, and there is something we do a lot more before even we could identify. So that's the segment that we kind of understood when we were at National Instruments, and that's when, with blessings of National Instruments, both Nikhil and I left NI in 2015 to go consult and then prove whether these problems are solvable with the approach that we have. So we took around 30 different industrial problems that were unsolved, and that's the only thing that the customer is going to give it to us. And we also wanted to understand it is easy to build all that I am saying at National Instruments because there is a huge team and precedents. There are people who have built that in the past, and then experience and everything that is there. Infrastructure is there. When you're on your own, it's a very different problem altogether for you to kind of build. So you also want to know how commercially viable is this? Is it even a viable business? So for us to kind of base it on this, and so that 3 years gave us that very good judgment, and then we took around 30 different systems where it previously failed, and we gave a 100% success rate on that with this approach. And we realized that there is a whole genre of problems which are solvable with complete confidence using this approach. And how do we productize this? And in 2019 August, we raised our first round of funding with Special as our key investor, along with Arali as another key investor. And the other problem that you also have is an entry barrier, right? As a hardware business, you can't just take a laptop and then start getting into your algorithm and then code, and then you have to build a whole physical system, and each system costed more than $300,000. So without the funding, we can't even do a prototype. So we started for a prototype first, and then hence we have evolved to wherever we are today over the past 5 years.
Yeah, that brings me to my next question. So what is your market like right now, and how are you planning to expand it further? Do you have any overseas customers right now, and how do you see that base expanding?
The market aspect is another entirely different. Again, it's over assumed market, I would say, especially from an academia and employment segment and investment segment. Of course, the people who are inside the market, they know them, customers. So incidentally, we don't have a problem in educating customers. We have a problem in educating every other stakeholder, which includes all the other employees and investors and so on and so forth. So the market is highly underestimated and understood market from the case. But that said, India is not our preliminary customer market, because commercial requirement to have automation is very minimal. So if automation in itself is very minimal, then robot-based automations in this is kind of lesser. But all the developed nations are our primary customers, with automotive sector have been obviously the first early adoption customers. We began our commercialization from January this year, and we released our Cyro as a full form factor as a product in May. So we already have Denso and GM as our customers at this point, and we are evolving as our basically our reference design customers at this point, to specifically put. And we would be crossing $1 million of revenue this year, since we opened to the market, and then possibly we'll be doing 2 to 3 million next year, and then the following year to kind of scale further from there. So, but this will stabilize for us. But that said, the way the market is organized, and so the price point of the robotic arm is not the concern for them, contrary to the popular perception. The maturity of the technology for them to adopt and for it to work for the next 5 years without any problem in their line is the biggest concern that the customers have. So in everybody who steps into this domain assumes that cost is a major problem, because you are taking India as a benchmark, right? Even in India, for the same price point, robots have already been adopted for welding problems, and even in India, welding is not done manually for any of the cars. Be it your Maruti, be it your Mahindra, be it your Ashok Leyland, be it your Tata, all of them are using robots for the robotic arms for their thing, and then each system is not any cheaper. So they don't have a problem. They have a commercial mechanism to make it work for that cost, right? What they don't have is a maturity of technology. That's the primary problem this industry faces, right? And all develop as we speak. GM and Ford, if my information is right, maybe I have to verify that, but at least what we have as a hearsay information is that they have revised their budget for one single automation cell to be close to $1 million, right? Yet they are not able to push that automation because the maturity of the tech is very, very inferior at this point. So there is no problem with the market, let's say, which is the counter perspective everybody thinks. Because they go and ask, if you ask the customer, they'll always tell you faster horses, right? Henry Ford statement, right? They wouldn't say an engine. So we need to look at the need. From the need point of view, the organization is structured to adopt these problems. But yeah, so that's a market landscape for us.
All right. I wanted to understand what's your approach towards innovation and what are your R&D efforts on that front right now?
Right. So the way we begin with is we didn't want to build everything from scratch. Contrary to what I was saying before, we try to take whatever that is possible that is already available from the market, right? Because they have proven to be matured. But that said, so there is a technology building, and so we put it as design, research, development, right? So design is the foundation aspect where we build the idea of what has to be done and the concepts that evolves and so on. So then whatever is needed to make it realizable comes into the research. The research will go into either experimentation, where if you don't have information available already outside, or you do a theoretical research on absorbing whatever that is already available and then build mathematical models on top of that, right? Then goes into development segment. So this is the pipeline that we actually have, right? Design, research, and development, right? Now, our approach has been to take whatever that is available from the market that is readily proven and established into the market. But that said, each of those components were built for a different purpose, so they don't readily fit our needs. So we have to do a significant amount of customization and a financial modeling around that to make that supply chain viable for us. So we have more than 400 plus parts that comes from across the globe, including Israel, Japan, predominantly coming from Europe, and Switzerland, and Canada, and France, and US. So name it, almost, obviously China also, right? So but from a predominant value point of view, it comes from price point of view, it comes from Europe, and you have to kind of structure a whole research around each of these components and how we could improve them to fit our design, and also to bring it to the manufacturability on the other side, right? So often these portions are missed when we think about from a research point of view. From a startup perspective, established organizations have dictated this very well, right? But the design sign-off has to go to a point where my supply chain works really well, and then my post-sales support also becomes important. So in that, we also segment them into pre-sales and post-sales effort simplification. How do we reduce our sales cycle to be shorter and shorter and shorter? And in that comes the development side of aspects, where I built my tech, but to be able to adopt the tech, the customer has to go through a lot of complexity. My processor works, but if I don't have a monitor and I don't have a keyboard, I don't have a way to kind of query my inputs and then outputs from the system. So how do we make them more sophisticated? That's another genre that we split them into to be able to make this whole machine much more easily accessible. We are selling to engineers at the end of the day, but the engineers should be able to put them together very quickly, not being able to deal with our bugs and things. So that's a development segment that goes independently. So this is how we kind of break them essentially into the formed layers for our cycle of design, and keeps coming back as feedback loop for us to build this further into the design and enhance.
Right. I also wanted to ask you, what were the major milestones that your company encountered since its inceptional phases, and which are the kind of achievements that you're most proud about?
In general, that I don't know how to connect with the word proud for the case. I'd be most proud when I see these systems possibly in everybody's home, or the kitchens come out of the home at the end of the day. So that's the imagination that we actually have. But of course, the significant milestones that has pivoted us really, or or more than the pivot is the wrong word, catapulted us to get to the things is there was one, the way we could handle COVID at that moment, because right when we started in 2019 August. By 2020 March, the shutdowns were actually announced, and the hires that we made at that time, and without hardware access, we cannot build anything on top of it. And the way we were able to crack through the supply chain at that time was one of the primary breakthrough at that point. Second, we were stuck with what was available. It was insufficient for the design that we made. So the way the robotic arms, even that the way they are today, in itself is a problem, right? And we thought we will not be able to build what we wanted to build because the robotic arms in itself were insufficient, and the way the cameras were actually coming about were also insufficient. But there were some things that we were able to figure out and then make this whole system work and then bring it to utility to a point, right? So that was another inflection point for us, that we over imagined what is necessary to be able to solve that problem. We could also just break that into cycles and phases where there is a incremental utility. So there's a statement that I keep putting for us henceforth: even God needed evolution to create, right? So the cycle of evolution, and you could bring utility instead of thinking of ultimate problems. Look at every phase, what exactly whatever that you have built, how can we take it to the market and then make someone feel an utility for it, right? That thought process for as an organization, when we realized, was a very pivotal moment for us, which also catapulted us to get to the market much quicker with much more utility, because we will start imagining Iron Man on day one, right? So the fantasy is going too high. So wishful thinking, the way Elon Musk probably puts it, right? So that trap was actually there. Getting out of that was a very significant achievement for us. Then the way we could figure out a global supply chain and make them accept everybody, all of that. So we think our investors are not just limited only to the people who put the money. Every component supplier has also invested in us as a company who is a nobody from Bangalore, to be able to convince a whole global supply chain to be able to modify their processes to produce the product that we want, or a component that we want, without charging us that extra, which would have ran to several tens of millions if we have to so that's the amount of investment the ecosystem has put into us, right? So that's another significant, the way we learned to do that was a very significant milestone again for us to achieve. Perspective, the rest is all is in the way we cracked the neuroscience of what's happening behind the eyes from a technology aspect. So we don't look to machine learning papers. We look to neuroscience for us to build our algorithms and things, and then the way we were able to manifest the utility, challenging every notion of how a 3D depth construction or a vision should happen. So, I mean, technically is how people will be able to relate to this milestone, but that's a very significant milestone also for us, that our thesis, stayed put in spite of all the challenges that were thrown at it, or the holes that were poked at us, right? So these are very, very proud moments, and the way our whole team came together around this, and then the way it organically grew. And in that process, one of the other significant milestones I'm also really proud of is the fact that for a size that we are, for the awareness that we have, last year we had 15,000 applicants for our organization. Our LinkedIn followership doesn't even reflect that, right? So and the year before that we had 12,000 applicants. So that's a massive inflow of that's another significant learning how to do that, to attract that amount of talent, to be interested in the jobs that come around this organization. Also is another significant milestone that we think we have done. And the final one is our ability to establish. So we have recently opened up an office space in Switzerland, to be able to go in there, identify that, be it within the ecosystem, with a significant support of Swiss government and recognizing it, and in partnership with EPFL, the university from where CERN particle accelerator came out, and Logitech as a company also came out, and to be able to associate with one of those labs in co-building whatever that you want to build in terms of further technology for robotic arms is another milestone I think we have crossed.
Fantastic. So I also wanted to understand which do you see are the industries that would invest in technology in the next 5 to 10 years, and which would adopt whatever you're building, your services as well as your offerings in the next 5 to 10 years, and what are you most excited about?
I certainly think adoption of mining from the waste will, because today if the industry organizes around them, that will become one of the primary adopters of automation. Then what we believe as warehouses and dark stores and those kind of places. See, automation generally for labor market in developed nations is a must. So they are definitely going to. So just from a pure economics point of view, at least mechanization and automation will become more and more. And automation doesn't begin with machines being adopted. It starts with processes first, and optimizing for people, using people first, and replaceable people first, and then goes into machines and so on and so forth. But from an robotics point of view, I do think one of the less appreciated and then less noticed space would be from waste mining, and that could be a significant industry, because you will, even in an undeveloped nation, you will find the cost of effort being very high for such operations. And I don't think street cleaning and those kind of things, getting to your home, will take much longer time. I don't think humanoids will make strides as much as we hope they would within the industry. And the form factor of robots might look very different from what humanoids are. And the focus towards, I'm slightly deviating from the question that you asked, but I think the supply chain that is needed to build the humanoid and the sensory aspects of it will become very high. That will be the new bustling thing that will happen. Then even the robotic arms being adopted in a large scale. And
those are the areas where job creations will happen, is what you're saying.
Will happen, right? Intensely. And what I think also is, more than they're becoming autonomous, training robots will become a new service industry. That's going to be, at least it'll, before that you always would need a decade of infrastructure maturity, right? So you can see the cycle happening. 1980s was all about building computers, right? Once that became, percolation of that became really strong, 1990s was all about software and internet building, right? Software organization and so on. So then came a dot-com bubble, right? Then the focus went again in building fundamental infrastructure, because it exploited and exhausted whatever the infrastructure that was already built. Then went into your communication network building to a very strong phases, where mobile phones, 2G technologies, 3G technology, 4G technologies has to be built more and more, and all these IC improvisations and things, embedded systems, digital one only in early 2000s. Till then, analog was actually very prevalent. We think digitalization happened long before it did, right? And all this as foundational infrastructure actually happened, and AWS was born, and so was there. That paved the way for this whole bustling ecosystem of services industry again coming on top of them, exploiting that infrastructure that was built in the 2010s, right, onwards, which again came to stop around COVID. With the maximization of, people thought Zoom will be the thing that will go, online meetings and remote work infrastructure will be the biggest thing, and so on. So where we were very strong of an opinion that supply chain is fundamental. What we take it for granted are the ones that will come back. Right now, supply chain is the prominent issue. It has become a national defense security issue to a large extent for many nations. Right, so much over $600 billion investment has gone into Arizona over the past. Raw cash has gone into Arizona for bringing semiconductor back into US. Right, so the way the economics would work around this is again from a infrastructure where I don't think a completely mature robotic arm would be there. But today, robotic arms are not going inside, where completely autonomous robotic arms will be there. Robotic arms are not going inside because the infrastructure needed for it to adopt is not well built, right? So simplifying the services will become or retraining robotic arms and redeployable robotic arms will be the future before the humanoids take over. right? And a whole service industry that will help train these robotic arms, build those robotic arms, will be the major segment that will come about in this case. So in my imagination, the future of service industry will not be something like Infosys where people sit in front of the laptops to code them. You'll be sitting in front of the robotic arms to train them different tasks and how should they do and what should they do and so on and so forth. So I think that, and teleoperated robot systems will come to us to a significant extent. All this is based on how we are able to percolate robot hardware to be in everybody's. You need an iPhone in everybody's pocket before App Store kicks in. Mm-hmm. So I think this is the line it will actually go into, and I don't think it will be one particular segment and sector in which this is going to percolate. It will be across all sectors, wherever physical labor difficulties are there, and the ecosystem to use them. Just like laptops did not decide which sector will absorb first. Every sector that needed data processing have had computers come into their place, right? So I think the same thing will also happen between robot assembly. What we have to trace is any physical object that we consume, their journey will have a significant percolation of robotic arms coming in between and robot systems coming in between. So that's how I would actually imagine the system to happen.
Any emerging technologies that are of interest to you? You did mention neuroscience that you are relying on very deeply to develop your products. So are there any emerging technologies that kind of excite you right now and you think you will be adopting it in the future?
I think if it again comes from NVIDIA stack and learning stack, I'm less hopeful. But I think even in the previous point, I forgot to mention this. We are jumping to intelligence before sentience. The whole layers of sentience will be built more. Robotic arms need a lot more of physical sensors around them, and they lack. People keep going and then building more and more robotic arms. The need of the hour is not the robotic arm, but the sense that machine doesn't even realize that it collides on its own body. That's the maturity of the tech, right? How do you even prevent them to go and understand how much force to apply on an object that you have to put, and so on and so forth. So you need a whole bunch of sensors that is to come inside, and I think that is what it will open up, and that's what the humanoid push will create. A more and more of sensors becoming cheaper, more actuators, sophisticated actuators. Today, a 5-finger hand will cost $100,000, right? It's commercially not viable to put them into a robotic arm, but that will become cheaper, right? So, and more significant tech has to come into building each of these. I'm looking forward to the evolution in the grippers. That's going to make a lot of transformation. And obviously, vision side, I would say we will bring those transformation that is supposed to happen. I'm also looking forward to how the sensors that are manufactured for the vision to evolve, but that is not being talked much. Just like how batteries were not talked much before EV became a common, that the leaps and bounds that the batteries have evolved and become efficient after EV as a market has come. That the same such transformation is not happening for image sensors. So I'm looking forward to some such modifications supposed to happen, because they think it's done and trusted, it's all done. But actually there is so much variation that is supposed to happen with the evolution of image sensors in itself, and I think there are some pivotal companies that are working towards that. And I think there is a lot of semiconductor oriented innovation that's going to happen. It's going to open up too, right? Which will make the arms much more efficient and much more capable and sentient in the way they can sense a lot of happenings that are happening around, and then they'll build around. So just like mobile phones brought out the IMU sensors, created IMU sensors, accelerometers and gyroscopes to be put into that. Similarly, and capacitive touch screens, there is a whole array of such sensory systems is going to come. That's what I'm looking keenly forward to, which will have a pivotal increment in the way the intelligence technology is going to grow. So all our ML algorithms will depend heavily on them. Reinforcement learning will depend heavily on them. They'll make them go exponentially faster, exponentially more efficient than the way we are doing now. And I don't think data is the way to evolve intelligence in the future. That I think will, if the robot systems become really, really heavy and percolated really well, it'll transition from data to a neural model based learning. One mod you will pick multiple models of neurons and then you'll start learning from them. Then to just live action learning is what will happen more. Lack of words, I'm just using these, but I hope the imagination kind of comes forward too. But I think it will transition from data into physical signals, signals and signals from sensors, and how do you collate those signals from sensors to bring a meaningful understanding of physical world around you, is what will go more into evolving tech and intelligence for that case, or the space of intelligence will evolve.
One more question that I had was about the partnerships that you are forming nationally and internationally. Are there any? Is there anything in the pipeline that you're excited about? Any kind of partnerships that's evolving currently?
What we are essentially looking forward to is more deeper partnerships with robotic arm organizations. Where so the problem is to build the system and then make it this precise from 1 mm to 20 micron has taken almost 20 years, right? I don't want to underestimate that, right? But they have to open up the platform, which they don't. And we need somebody with whom we can co-develop it. We don't want to reinvent the whole robotic arm from scratch, because we have a whole layer that we have to build on top of them, right? So we would rather want to be the Apple than to be an Intel at this point. And what we are going with to the customer is a laptop equivalent, where the same hardware is usable for. So I need that whole partnership that is supposed to come along with them. We also need partnerships with image sensor manufacturers, which are vying, and optics and image sensor manufacturers. Today we are trying to use commercially available sensors, which is best available, which is not the best suited for the application that we want to do, to be more efficient and faster. We also want to build a vertical integration of sorts for sensory capability, and also gripper building associations, and motion aspects. So in all of these aspects, we need more partnerships. We're also looking for more partnerships on the research labs, which research intelligence in itself, and which research machine learning methods beyond what is not in terms of applying the machine learning methods, but building new machine learning methods inspired from, if not exactly imitated, at least inspired from the way the human intelligence has evolved, or the human layers of the brain layers, neural layers in the brain has actually evolved, and so on. So these are the additional aspects that we need help, and a lot of the problems that you identified in all of the sectors, we need people to kind of collaborate with us to build as a whole platform. Eventually, what we want is an ecosystem to build, because this is a very nascent industry. Competitors are better than being worse, right? We need this whole ecosystem to evolve, and there is enough space for everybody to come in and play. There is no necessity to even compete. There's so much complementing that has to happen within this whole space. There is so much to discover, so much to build. So those are partnerships that we are keenly looking forward to, apart from what we already have had. We have had one partnership with one key laboratory at EPFL, where it's for building an OS to manage multiple arms, to say how they should do a task. Should the right hand go for the cap and the left hand for the pen, or the otherwise, or where should I actually mate? How should I mate? So these are all, this in itself is an less understood problem. So you have to build a whole OS layer on top of them to say who should do what, how should they do, what will be the fastest, which way to come will be fastest, who should apply force, who should resist. So the small things that we ignore in itself is a whole large space of study, the future OS of hardware systems, right? So that's something that we have to build. So these are all different aspects of partnerships that we look forward keenly to. And of course, money and investors are other aspects. I'll come to it.
Right. All right. My final question to you is: what do you see is what is your vision for Cyn Lr as such, and what do you think it should achieve in the future?
I think, if you come to our office, we have a whole map called vision. So I don't believe in this namesake statements of one-liners that people actually put. When you're building a fundamental technology, the vision must be a science fiction that you're imagining in your head. The transformation that you can bring about in different small things, big things, doesn't matter. But you should get into that imagination. One of the biggest things that we imagine, at least from our point of view, is factories becoming universal, where whether you're making a car or your cell phone, it comes out of the same factory, right? It feels kind of impossible in a certain way, or it's counterintuitive, but it's the same way in 1980s in your table, in your desk, that famous picture where you used to see so many devices that used to be there to process data, because data used to come in different material formats. There was one CD, there was one gramophone, there was one magnetic disc, there was one paper. They all were containing different data, and then sound, and so on and so forth. So you had a fax machine, your printers, calculators, and so on and so forth, right? Typewriters and so many. All of them just became one device, right? You universalize that, right? We need to kind of bring the same transformation about for factories too. And then I don't think future of the factories will be your mega factories and giga factories. I think it'll be more of micro factories sitting under your apartment, uh, customizing for your consumers what they want. And one of the biggest vision that I envision, that I feel will happen is how your house will look like is you will not have a kitchen in your place. It rather would be more centralized and then kept outside, because now you could immortalize your grandmother's recipe. A recipe is just a sequence of actions that you're doing on some of this material in the way that you do, and you could teach that into a robotic arm, and the robotic arm will be able to or robot system will be able to kind of make that cooking thing. So you could also commercialize your recipe of your taste. You don't have to establish a restaurant and then do a Britain motor business and Rameshwaram cafes to be able to build all that taste, and then monetize the taste that you actually created. It could be just someone downloading from somewhere a recipe, and then your system is already kind of cooking it, and then it's giving you that taste, and you will have the consistency coming out of that system. So I think these are transformations that we actually look about, including consumer mining, right? As another vision that we actually have, where I don't think in the future, if the effort is free, today the effort to extract, so all the cost is all about effort that we put. If my cell phone has reached its end of life, I'm not going to produce a new cell phone. I'm not looking to the same cell phone for the raw materials. I'm looking to the ground to get the new raw material. Why? Because it's cheaper, it's easier, less effort consuming. But if I make the effort free, then it becomes even more easier for me to, when it comes out of a mission, you don't have to pay them salaries, right? So it just transforms the way the world will start using those machines to extract material from consumers. So today the biggest consumer is the dustbin. Eventually all your material, the dispersion chain goes into your dustbin. I think dustbin will start becoming a dispersion chain instead of just being a supply chain, right? So it will go back. So that transformation will also look very, very different. I also think farming will transform from the front. So these are imaginations that we keep having, science fiction that you want to go into, and then we start narrowing down to say, maybe I may not even be alive to see many of these transformations. It's going to take a much longer period, probably 50 years, 60 years, and so on and so forth. But universal factories might take even 100 years. I don't know. But the pivotal technology will be what we build now, and that's the imagination that we go drive towards. And on the way, we may consolidate some of those industries, including building the service industry for one of the biggest things that we do is every time the system starts learning this, the system learns about the object, and then it has built a neural model of this object in itself, of all its three-dimensional neural model of this object with all the sensors and feelings and things, right? And every time you do that, you don't have to keep training for it again and again into a new object. So you are creating a repository of, or a store for objects, like an app store. You have an object store and a task store. The customer will start, paying for each of these whenever they want to kind of start using these in the same hardware. Whenever you want to download an application, you'll have a monthly subscription and so on. So that, like that, you might be using for each and every object for whatever the level that you want to use. So this is one imagination, or the bigger goal for Cyn Lr in itself that we keep, than for the market transformation that we look at, right? So our aim is to take these robotic arms as a standard form factor for any kind of tasks inside a factory. And once you have done that, standardized your factories with just one type of item instead of variety of machines, when you have consolidated that, then you have a whole market that comes after that, which is predominantly on the service segment, where you will be retraining each of this, and then people will be subscribing to those part trainings and object trainings.
Well, all the very best with that. So I'm like really excited to understand and kind of, I mean, my interaction with Cyn Lr has been the most instructive so far. In the last 1 hour, I've learned so much that it is kind of very interesting that I have never touched upon this field of artificial intelligence or machine learning and cybernetics per se, and it has been very very insightful and an inspirational conversation that I've had with you. So I hope to have more such interactions in the future, and I wish you all the very
Absolutely.
best. And I look
Absolutely.
forward to everything that is coming from your end, and all the very best. And thank you for having this
Thank you so
interaction
much,
with me
Pratibha.
today.
Thanks for the pertinent
Thank you.
questions too. Thank you. Thanks.
Thank you. Thank you.